no guarantees.
Gotcha.
So now we got 5 minus 14. 5 minus 14 minus 9 equals 8. So since this is a no, it is not. You would say not a solution.
Mm-hmm.
And then you rinse and repeat here for the next ordered pair.
Wait, sorry, could I write that one down?
Of course. Of course, yeah.
Sweet.
I'm sorry. The second one, it does work. I wrote the wrong number here. I was looking ahead. I'm like, why don't these work?
Oh, okay.
Okay, so yes, it does work in both. So yes, it's a solution.
So they both need to work for it to be a solution.
Exactly, yeah. Okay. Same thing for the next one here. Yeah, this is X, this is Y. Try it in the first one here. Minus 3 times minus 5 plus 7. Does that equal 8? I'll let you tell me yes or no on that, please.
Okay. No, it doesn't.
Does not. So that's enough. I mean, you don't have to go any further than that. You just say nope, and you move on.
Sweet.
All right, let's try number 4. Let's try that first ordered pair.
Oh, sorry. Well, actually, it's fine.
No, go. What were you?
It was 1 through 4, and then 14 through 22 the evens.
Okay, we should do number 3 then, because it's got some fractions in it. That could be a little bit more challenging.
Okay.
If that's okay with you.
Yeah.
All right. Okay, so number 3.
X plus
All right.
Y.
So first one here, you just put in for X and Y. It's 8/7 plus 6/7. Does that equal 2? When you have the same bottoms, you add the tops. And yes, that does work. Let me know when you're good on that. We'll do the second one.
Okay, we can move on.
All right, so the second one again, you got X and Y, so you're just putting those numbers in. Is 6/7, it's a question, 3/4 times 8/7. And one thing you might consider do is what's called pre-reducing, which means if you can divide like 4 goes into 8 2 times, and then to multiply fractions, you multiply the top numbers, 2 times 3, 1 times 7 becomes 6/7. And it does in fact work. Any questions, thoughts on that?
No, it makes sense.
Okay. Why don't you try the next ordered pair in the first one?
Okay. So B. 1 and 3/4. One plus 3/4. Two. Two. And then so the first one doesn't work. So we just move on to the next one.
Yeah, so if it doesn't work, I mean, reality is there should be only one point where they both work. But
Mm-hmm.
it's there are potentially some other situations, so we just move on. Okay, which is the next grouping of numbers? I'm sorry.
And then it's gonna be, or no, we can move on to 4.
Okay, you want us to do 4?
Mhm.
All right. Okay. First set of ordered pair, or first ordered pair is -6, 2. So we'll try that in the first one. Here's 2 times -6 plus 3 times 2. Does that equal 6?
No, it equals -6.
It is not. So we stop. Like there's no reason to go any further than that. And then you grab the next ordered pair. Right, and so the next ordered pair here, do the same thing. 2 times -3 plus 3 times 4, does that equal 6?
Yes.
Yeah, this one works. It ends up being -6 plus 12, which is 6. So now you got to try it in the next one. So does 4 equal 2/3 times -3? Now you can write -3 as -3/1 plus 2. It's kind of up to you. Like you can pre-reduce like I was showing you, or you can just multiply across the top and then you reduce. Doesn't really matter. You gotta decide what you'd like to do. This ends up being -2 plus 2, which is not 4, it is 0.
Okay. Sweet. So that one we can cross out and then
Yeah.
just move on to
Yeah,
14.
you're gonna get a question on your tester quiz, which is just, which of the following ordered pairs is a solution to the system? And just make sure you try it in both.
Mm-hmm.
Yeah, so what's the next problems you want us to look at?
I'm sending them over right now.
Sounds good.
And then I think these are gonna, yeah, these are gonna include some graphing.
Got it.
And so that's going to be 14 through.
And you have to solve by graphing. Yeah, that's what it looks like.
Mhm.
Okay.
14 through 22, the evens.
All right. So for 14 here, there's a couple of ways to graph. When they're in standard form, these are in standard form. You first look to see if you can do what's called the intercept approach.
Mm-hmm.
So for the first equation, 2x, actually, let me do the second one. That'll be more straightforward. The intercept approach, you set x equal to 0, and you're effectively like eliminating the 2x because 2 times 0 is 0, and then you're
Mm-hmm.
solving for y. So this becomes 3y equals 12, divide by 3, and y equals 4. So your ordered pair is 0, comma 4. Have you seen that before?
I think I have.
Okay.
Yeah, that looks familiar.
Then you have to set y equal to 0. And that's like saying, okay, 3 times y is 0, so it goes away. It's just 2x equals 12, divide by 2, divide by 2, x equals 6. 6 comma 0 is our set of ordered pairs. So we know 0, 4 and 6, 0 are on the graph. You can draw a line like that for the first one. Is that okay so far?
Yeah, so just give me 1 second. Our teacher said these like the graphs need to be like
Really good?
precise. Yeah, so
Oh, okay.
sweet.
Okay, you want to do the same thing for the top equation. You're going to set x equal to 0. 2 times 0 is 0, so it just becomes minus y equals 4. The negative always goes with the one on the right. You divide by minus 1, and y equals minus 4. So that's your first ordered pair, 0, comma, negative 4. And then you do the same thing for y equals 0. You don't actually have to write all this out. Like you'll eventually be able to just do it without writing anything because you're
Mm-hmm.
just covering up the variable. And you have the other equation. Usually you can solve it in one step. So there's your 2 points, 0, negative 4, and 2 comma 0. So we go back to the same graph and graph these.
Sweet.
And one of the reasons these graphs need to be so good is that you're supposed to be able to determine the intersection from the graph. Looks like it's 3
Mm-hmm.
comma 2.
Oh, wait. So it's x. Or no, x is
0, -4, and 2, 0.
oh okay. And then 2 was the x. Okay, sweet. Mm, sweet. And then the intersection point was 3, 5 or 3, 2.
3, 2.
Sweet.
Okay. What's the next one you want us to look at?
16.
Hmm, okay. The reason we use the intercept approach is because both of these numbers, the coefficients went into the right side. Doesn't look like that's the case for the next one. Get it up here on screen. So for 16, you can for the first one, you can still use the intercept approach. And that's probably what I would do here. I would for the first equation, I would set x equal to 0 and find y. You'll find that y is -3. Like that's how quickly you should be able to do it, because you're envisioning that x is no longer there. 2y equals -6.
Mhm.
And then you do y equals 0. So it's as if you're covering up the y term now. -x equals -6. You know, if you need to write it, that's fine. But you'll get x equals 6.
Sweet.
And so the key is, like you said, you got to graph these pretty reasonably. 0, -3, 1, 2,
So then
3,
y
4, 5.
is the y coordinate is going to be 0, 0.
No, 0, -3. You always pair one x with one y.
Oh, okay, there it is.
Yeah.
Gotcha. Grab that.
Is that okay for the first one?
Almost just drawing the graph.
What you got to kind of close out here. The second one is in mx plus b form. The
Okay.
slope is the number in front of x, the b is the other number. And when you
Mhm.
graph it, you start with the b value. So you start there at -1, and then use the slope. The slope in this case means down 1, right 2.
Mhm.
And you plot enough points until you know, you find the intersection, which
Yeah.
is right there at 2, -2. If
Sweet.
you're stuck on any of these, use Desmos graphing calculator to graph them, make sure it looks the way it's supposed to.
Okay.
But
Yeah.
that is going to be all we've got time for today. So good job. I'm going to stop the recording.